Hello, everybody. Good morning, afternoon, evening, from wherever you're tuning in this beautiful world of ours. Um, Welcome to one of the most exciting webinars we've had this year and probably ever. Um, we'll just give everybody another minute to join. I know we're also a few, like a minute or so, five-ish late. Um, and we'll get started in just a bit. If anybody is seeing any weird stream issues, please let us know in the comments and feel free to post questions. Well, if you're watching on YouTube or Twitter or whatever platform is of your preference, um, we'll try and be there to answer them. So without further ado, I'll just get a quick intro. We're going to be talking about enterprise artificial intelligence today. And together with me is our special guest from Microsoft. His name is Chris Coulthrust, and he's going to be sharing immediate firsthand experience of deploying production AI to production in the enterprise environment of Microsoft and their clients. Chris is a principal solution architect at Microsoft, possesses deep knowledge of AI, obviously with quite a lot of experience in development of applications and business operations. He works closely with customers on data and AI strategies and their teams, and really, like I said, bringing the solutions to production. So it's a very, very short intro. I believe it would be best to let you, Chris, also pitch in, but I would also love to hear from you and perhaps if you could share a fun fact and about yourself and what you've been excited about lately.
Oh, yeah, thanks. I'll share my screen if that's okay. So
Be
my
my
name's
guest.
Chris
Go ahead.
Yeah, thanks. Chris Coulthrust. I work at Microsoft. This is my LinkedIn profile if you want to be my LinkedIn friend. So like we discussed, I work a lot in AI, agentic systems. My fun fact is this is a dress that I not only designed but fabricated on a CNC machine in my basement. So my hobby is I am a shoemaker and also an occasional dress designer and fabricator. This is Kendall Jenner wearing a dress that I made in Vogue magazine. So that's my fun fact. So yeah, should I go right into what we do and how we do it?
Fabulous. Yes, Chris, if feel free to just take it away. We'd love to hear
Yeah,
what you
let me
have to
take it
share
away.
on your latest.
So I wanted to just level set on a few things, like what is an agent, right? What is it at Microsoft? What is it in the zeitgeist? It's really an AI application that has language model, instructions, tools, maybe. And very simply, there's some inputs, whether they're user messages from another agent. Then there's some outputs, right? Whether it might be an image or a message or some tool results. And then there's tools or affordances that the agent uses. So that's basically it in terms of agents. Now we get into an interesting thing. I build a lot of different. I work across industries. I build a lot of different agentic systems, everything from like health and life sciences to financial services to manufacturing. They all use the same platform and tools. There may be some different data and different instructions. And so I'll go through a couple Microsoft slides. We have a lot of different ways to build agents at Microsoft. So you can go everything from pro code with semantic kernel or autogen to platform as a service with our AI Foundry service, where the agent is a pro code agent but hosted at Azure on Azure. To our software as a service sort of enterprise product, Copilot Studio, where you can build an agent as easily as describing what you want the agent to do. And that agent will be assembled and connect to your internal enterprise data sources, et cetera. So we have the whole spectrum of solutions. I'll get into a little bit about agentic scenarios and then talk about some of the projects that I do. And feel free to ask questions. Happy to go through this. Oh, yeah, I forgot this slide had a couple extra things. So as we go from right to left, we increase control, visibility, and customization. Obviously, use semantic kernel or LangGraph or LangChain. You have full control of the code over the memories, etc. And as you go to Copilot Studio, it's more of like a sort of citizen developer type of product. And then the platform integrations, ease of use, and development speed as you go from left to right gets easier, right? So this is made again for citizen developer, on the left, pro code developer. So we support all of this and everything in between. I'll go high level agentic scenarios that we work with. So there's deterministic processes, right? Like our traditional software. And it's important that we don't forget about traditional software development, because interestingly, the more AI and the more agent work that we do, we rely on traditional software development lifecycle and good software development practices. So a deterministic process is something that you know how the workflow goes and you have a deterministic outcome. So like send an email, you know, when you put an email address, you push the button and the email is going to go. So that's traditional software. And we go down here to the bottom, we have a probabilistic process with a deterministic outcome. So probabilistic is, think about that like your agent or language model, like probabilistic, stochastic, sort of random, not the same every time, is what these language models many times can deliver. And you might have a loan reviewer, right, which is probabilistic, where you don't really know all the documents you might get, or the maybe many different types of loan products you're approving for. But you know the outcome is going to be either like an approve or deny of the loan. Up to the right, these scenarios, customer support and marketing campaign. I do a ton of these. Deterministic process, like you want to sell something or you want to answer a customer question. Probabilistic, you're not really sure where the data might be or what the customer may be asking for. And down here at the bottom, our last sort of iteration of this is probabilistic outcome and probabilistic process, where like a scenario is research. When you're researching, not really sure where you're going to get to or how you're going to get there, and that's what this is. So you know these are like the high level sort of design patterns that we see, and we address each of them with different tooling, right? And I'll get into those. I'll try to talk a little bit fast to get through some of these. Then in terms of agentic systems, so the agentic path, we have single agent, right, that might do very specific tasks. And I have a slide in here. Customers ask, well, you know, how many agents should I use to do this task? Or if I have a big task, how do I think about breaking up the task to different agents? Some people, like when they're prototyping, maybe they'll do a single agent that does very specific tasks, or when they're really starting out, they'll do one agent and just sort of pack it with things and sort of overload it. So good software development is like to make things as modular as possible. Why? Because they're more easily testable and maintainable, right? So you think about like, you know, developing microservices or developing in Python or C#, you develop classes and your software is very modular, so you can plug and play. So anyway, single agent, single task. When we move to multi-agent, this is where we take multiple single agents and sort of tie them together in some sort of conversation pattern. And we're able to solve like very, very complex tasks, with these, right? And then off to the right, we get into these agentic enabled business processes. And this is really where I live, where you have deterministic enterprise processes, and they're stateful, right? So if we take an example, I'll explain that one. If we take an example of, we just mentioned a loan reviewer, right? The process when you apply for, say, an auto loan or a home loan, you'll submit an application, maybe multiple paperwork. There'll be some back and forth with maybe loan officers. We'll check your credit, and you go through the whole process. And it's really that, if we think about it, that's really a long-running process, right? And at different steps, we'll need to interact with the customer or other stakeholders differently. But there's an overall process of how we want to do that, right? Like check the credit, check the income, check the whatever. And that's a defined business process, and the human in the loop. So many, well, I'll say all companies, to make it a very general statement, have these standard operating procedures and how we do things. And so I work a lot on like, how do we capture that and describe that to the agents so that those business processes are agent ready, right? And I do a lot of work on that. How do we get there? That's a different story. We use things like process frameworks. Process frameworks is most of it. We use memories. We think about long-running processes, et cetera. We'll go into the spectrum of agentic solutions. I probably should have done this first. So a no tools agent, right? Well, this is, you just have like, you're giving the agent some information. You have a language model and a prompt, and maybe you get a summary or a data extraction, right? A single agent scope to an iterative task. Like a great example of this is you ask a question to an agent, and this is like standard RAG stuff. You query one or more data sources, you get data back, and then you run it through the language model prompt, and then you get an answer. The differentiator here, I think, when you give it to the agent, someone might ask a question that's very general, right? And what you really want your agent to do, and we have Azure AI search agents that do this, is think about rewriting the query, or maybe if you have multiple data sources, this agent will figure out like, these are different data sources I can query, and sort of marshals that whole process. And then there's this sort of summarization answer step. And then going to the right, we have these multi-agent systems, where we have really complex use cases that require multiple diverse skills, right? So we have, like we talked about before, single agents with very specific tasks. So this one's doing service agent, this one's doing retrieval, this one's doing analytics, one's coding, this guy's coordinating, and this guy's just a user proxy, and then there's memory. So this has become like sort of state of the art of these multi-agent systems, where we put multiple agents together to achieve a task. The thing that I just talked about before, these deterministic processes, right? Like, you can ask the agent, like, hey, do this thing, and let the coordinator agent sort of figure it out based on the tools and other agents that exist. But you're open potentially to, if the agent is just figuring out its own, you're open to hallucinations. Also, the process has a very low probability of being idempotent or repeatable, doing the same thing every time. And if you do want that repeatability, you need to think about process frameworks like a LangGraph, a semantic kernel, AutoGen, and understanding how you sort of encapsulate that business logic so the agents can understand it. Again, making the business process agent ready. We'll talk about orchestration design patterns. And this is very general, like not just Microsoft. These are sort of best practices and design patterns. So sequential, right, where you just go step 1, step 2, step 3. Concurrent, this is also a fan out pattern where maybe you want to search three different knowledge sources with the pattern. So you might fan out and then fan back in. Handoff, similar to concurrent, but then the agents sort of talk to each other to get to a task, right? Group chat, this was fairly simple. You have one or more agents that are all speaking, and then you might have like different group chat patterns where it might be sequential, round robin, random based on the capabilities. Magentic, this came from Microsoft research. So you have multiple agents and there's interactivity going back and forth. So different than concurrent, because this is like a directed graph. This one is potentially cyclic, where there's feedback back and forth from the agents. And then this one here, the workflow process is what I've been sort of talking about, that how do we bring the deterministic flows to the agents? Well, this workflow is like, how do we take the standard operating procedure again, describe it in a way with the process workflow, and use that to drive the agents, right? So you have event-driven process workflows like semantic kernel, LangChain, LangGraph, those sorts of systems, Crew AI, just to mention a few. So this is super important for enterprise, right? Because we want to understand how the process is going to work. We want to understand task adherence. We want to understand, did the agent do what we expected it to do, et cetera. I'll stop for, are there any questions in the chat, or am I just going on and on? Yeah. So if there's any questions, let me know. So back to the question that I originally posed, that customers ask all the time: when should I use multi-agents over a single agent, right? And so this is just a really quick, a quick graph of, these multi-agents can solve more complex systems. And if you look down here, there's when GPT-4 was the state of the art. You have a single GPT-4, doing this task at 88%, and you have GPT 3.5, right, and multiple GPT 3.5s performing the task here is the multiple GPT 3.5s at 88%. So you can use a smaller model, which will be, of course, faster, right, and cheaper to run, and maybe run locally. Is able to get close to what the GPT 3.5 multiple is able to get close to a GPT-4, and then a multiple GPT-4 is able to get really high accuracy. So these are some sort of general numbers, and this is, when you have these complex tasks and you think about like how do I break these tasks up? I think about it really like, how do I make my code more modular, and how do I really make these agents specialized to do certain things, and then orchestrate them together with these process frameworks. Hopefully that's useful. One other big problem in the enterprise is a lot of things are in POC. This is not a secret. This is highly published a lot. Like, companies start POCs and proof of concepts, and they have a hard time getting to production. So this QR code is a seminal work from Microsoft, and how Microsoft, and it's all open source, you can find it on GitHub, is how Microsoft, the learnings that Microsoft had when agentifying or deploying AI into Microsoft Finance, right? So this is lesson learns there. And it really goes through like all the important things, being agile, having a great data foundation, getting the process right. So being able to describe that business process so the agents can use it, super, super important. Focusing on the AI integration, right? Like focusing on improving the employee or the user experience, right? Focusing on boosting efficiency, mitigating the risk that going fully agentic or using AI might have. And really it talks about like having a culture of agility and flexibility and change, aligning with your business strategy, your processes, and probably most important for me is the data estate. So read this. It's a long read, but super interesting. And what does it give us, right? It is like a really important work to read about industrializing AI. And the work is called MAVA. It's the Microsoft AI Value Accelerator, right? So it helps you, and it's really important for the customers I deal with and all enterprise customers, strategy and planning out the platform, the operating model that you're going to run, the security, responsible AI, which is super important, understanding how to scale it once you have that amazing POC, engagement and adoption, process and change management. And I won't read all these things, but all of these are super important. So this is like a masterwork on how Microsoft actually productionized artificial intelligence in one of our most important operations. And this also is always evolving. So one of the end results is, what we really want to do is when we go into customers, everyone's got a great idea how to use AI. We want to be able to take these use cases and really have an AI factory so we can experiment with different ideas, pull in these use cases, plan, design, develop, and deploy. And you'll notice here the development and planning and designs is really a cycle. Deploy as quickly as possible, right? So we can understand if that great idea is actually delivering the insights and the efficiencies that we have. So it's really, you notice these lines, it's like a continuous feedback loop, because as usually in all engineering problems, as soon as you fix one problem, you may or may not create several others, or you might change the way that people work. One big question is like, oh, I just did this agentic system. We made our people, number one, the CEOs and CXOs want to know how much more efficient the people have become, or how much more efficient the process, how much, what is the return on investment? You can phrase this many different ways. So we want to design that up front, right? And we also want to make sure that, like, again, the question is like, what are people doing with all the extra time? Are people taking more breaks, or am I showing a measurable return on investment for this, investment I just made in AI, right? And how do we do that? How do we use AI to improve efficiency of the corporation? So this is our factory model. The conceptual architecture, this is all in the documentation that I just shared earlier. But you'll notice, I just want to touch on this really quick. The first few the first few items are all around data, right? So data acumen, like understanding your data, having the right technical competencies, the domain knowledge about the data. It's really all about data, right? The data governance and operation, super important. I don't do a project unless I have a data catalog and the proper data governance in place, right? Because there's reputational risk at stake. If data were to get loose or the agent were to say something that it wasn't supposed to or divulge some information, not good. We have a secure by design initiative at Microsoft, and we have secure by design foundational architectures. So we build this security in. We have content monitoring and managing services to prevent I want to say dependency injection, but prompt injection. We have task adherence. We have all the tooling to support your responsible AI. Anyway, back to the data. So having all of the data also agent ready, in addition to your business process agent ready, having those agent ready is super important. And then we have the enterprise services, right? The directory services, IDP, identity provider, monitoring services, logging, security, policies. All of these things are super important. And if you don't have all of the things described in Maeva, your product will never go to production. So you have cool demos that no one will ever see the light of day. Okay, so check that out. Other important things, I'll fly through these. Design thinking. This is a course from Microsoft on user experience and design thinking. This is super important. I'm doing a lot of projects around voice now. So voice powered AI, and Microsoft just released a public preview of the live voice API. So customers are really interested in a voice level user interface. It's super important, and we have avatars and engaging that way. So, and is the chatbot the best way to interface with AI? Maybe for some applications, but there's interfaces that we haven't even thought of, and user experience that we haven't even explored yet that are going to be coming. So it's really important to understand, how can we create an amazing user experience with this product? Design thinking is the key to that. Other things, I touched on this a little bit, an article on how Microsoft is redesigning work with generative AI. Read this, again, super important when you deal with enterprise and your stakeholders. Like, they're going to want to understand, bottom line, I'm investing this much in AI. What is it going to give back to me, right? Like, if you've been in enterprise long enough, people have done lots and lots of projects and migrations and all kinds of projects and bought software. It doesn't always return. So, the CTOs and CIOs and CXOs are very, very aware of this, and they want to make sure if I'm going to pivot on this technology that I do it right. You don't get a lot of chances to do transformational projects in technology of this scale. So we need to look at all the things, right? The change management, the adoption, the re-engineer these business processes, which you absolutely will have to do, and all of those things. Again, transforming user experience with AI. This is another great article from Microsoft about transforming user experience with artificial intelligence. I can't overstate this enough. It's super important. Let's move on. I'll get into a couple quick platformy things because I'm a developer at heart. Process-driven orchestration. So I've been talking about these workflows and deterministic process workflows. So what are these things? There's a few platforms. This is originally from Microsoft Dapper, and there's Dapper AI and Dapper Agents. So check this out. What Dapper is, it separates the concerns from your application to the things that you connect to, like storage and event queues and other services, right? So there's a message broker, and they've extended it to AI agents. So there's an agent with the message broker to communicate with other agents. So why is this important? It's important because when you have one of these long-running process or any process running in the cloud, you're not guaranteed that the endpoint is going to be listening at all times, right? There's timeouts, of course. There's failures in data centers. There's cut cables. There's all kinds of things. So we need to make sure that these agents don't fail if there's a disruption of service, and that the agents and these agentic systems are durable and restartable, and they can pick up where they left off. Because imagine if you got to the end of some long agentic process, you paid for all those tokens, and it fails on the last step because someone kicked the plug out of a server someplace, right? That's a euphemism. What you want to do is be able to pick up where you left off when the agent started, right? Because some of these, if you use researcher agents, some of these processes do take a while. So check out Dapper Agents. It's super, super interesting. Other platforms, other multi-agent platforms, you might have heard of AutoGen, state-of-the-art SDK from Microsoft Research. There's also this is semantic kernel. Here is a process, event-driven workflow, has event-driven process workflow, sorry, and also all kinds of agent concerns. Also available in Python, C#, and Java. AutoGen is Python and C#. So here, where Microsoft has designed these platforms to speak in the language of the enterprise, not just Python, right? So they have a shared agent runtime below, and they're really interesting agentic frameworks to build on top of, right, that address all the enterprise concerns of security, durability, et cetera. And then we have a platform called AI Foundry, which I can show you. I don't know how much time we have, but the AI Foundry also has the ability to, from AI Foundry, you can deploy all of these services and AI services that you need, and also host these agents, host them as agent as a service on AI Foundry. I don't know why that was so hard to get out. So check those out. Other things I want to touch on that are important to agents, we said in the beginning slide, are memory. So what are memory? Memory could be just the contextual memory of the chat. Like early days, you would just send in like the last 5 interactions with the chatbot. Now, memories have gotten a lot more sophisticated. So there's a platform, an SDK called Mem0, which is a super interesting self-improving memory layer for language model applications. They have a dashboard. You could try it out. It's really great. But when you add memories to the agents, like it's really helpful when the agent, if you wanted to, remembers who you are, what you've been working on, understands the context, and those memories can also be shared to other agents. So super interesting area of development and research and memory and working with agentic memory. And so check that out. Other things are other forms of memory, right? We talked about, well, we've been listening to a lot about MCP. MCP can have memories, right? Because it can have resources that are databases, which are memories, and it can also have tools. So these slides are slightly out of order, but this is deploying working with agent-to-agent communication protocol on MCP on Azure. So check this out. But the slide that I really wanted to show you was this slide, which you might think has nothing to do with computer science or computers, but it's a really interesting book on introduction to neuroscience. And when you read this book and go to the memory section, it talks about how our brain organizes memories, right? So declarative, non-declarative working memory, semantic memory, episodic, there's contextual, there's long-term, there's short-term. And when you look at a project like Mem0, it really, it's important then when we have a user experience that the agent seems to be thinking or remembering the way that we expect it to remember, right? It wouldn't be fun if you had to repeat something to the agent every single time. So I would say if you haven't studied neuroscience, at least give a read through this, and you'll get a good mental model of like why these different types of memory are important to agents and also to humans that are interacting with agents. Were there any questions so far? Stop for a second. Okay, so this again is another shameless plug for Mem0, which is open source, and they also have a software as a service version. I would encourage you to check out this Mem0 dashboard, so you can set up an account, and it gives you a little chat bot thing. And so I talk to it and practice, like understanding what memories it'll remember and keep, and it's super cool, and it makes the AI obviously work better, and it seems to be. It feels like it's remembering all the things that I want. So it creates an amazing interaction. Okay, we'll move on. So we're in this era of multi-agent orchestration. We'll talk a little bit about some of the things that Microsoft is doing. So this, if you scan this QR code, in AI search, we've added multi-agentic retrieval to AI search. It's a feature you can turn on. So here, very simply, there's a query, right? Someone might want some data out of AI search, Azure AI search. Azure AI search is a search engine that allows you to index your own documents and then use those as context in your agents, right? So it's a search engine on your own data. So the query will come in, and what it does is a query plan is developed, right? So use an OpenAI model to develop a query plan. And it might take that query, like let's say I want the latest cooking recipes for something. So it'll take in the conversation history if I've been talking about chocolate cake and jerk chicken and other things. It'll take all that context and come up with a query plan based on who I am and the context that I've been working in so far, and potentially divide that into n number of queries, right? By rewriting the query and sort of send those queries out to the search engine, right? So I might search for all three things that I've been talking about, right? So to rewrite the query, retrieve, and then re-rank those results, and then merge those results together, and then send it back. So this amazing. It's amazing when you have the agents, right? It's like giving the question you have to a bunch of experts that are going to have some different ideas of searching, and the agents go off, right? Like single task agents that search, but they have their own perspective, and they'll go and search and bring those answers together. So if you have a chance to try it out or read about it, it's actually amazing. So this is one example of how we're building agents into some of our projects, in this case into Azure AI Search. Let's see what else we have. This is a quick slide that I had of like the evolution. I really appreciate Daniel Kahneman's book, Thinking Fast and Slow. This is another one similar to the neuroscience. When you read that, Thinking Fast and Slow, like the thinking fast is very much early days of AI, zero shot, few shot, and you get up to retrieval augmented generation, adding tool calling. And as you move from left to right, we get to much more, and as we go up here, the task complexity and automation are going up. And we start to approach like what Daniel Kahneman describes as this like deliberate system two sort of thinking. So similar to the neurology book, if you have not read this book, I'd say take a look. It gives a really interesting roadmap as to like, what are different ways of thinking, and I think it'll give you a great mental model on how you can orchestrate these agents and give them sort of thinking system two level thinking, where they're being really deliberate and long running. So that's interesting. AI Foundry, I mentioned, put this up for the Microsoft crew. What it gives you is a AI agent ecosystem, right? So you get everything in here from being able to add knowledge, Microsoft knowledge, and external knowledge that's not Microsoft really easily. The enterprise trust with virtual networks, bring your own resource authentication, managed identities, which are, you're not using API keys with managed identities. It's all run out of the Microsoft Entra identity provider service. So it gives you this like level of security and trust, because you're not passing API keys around, and auditability and control. Then it supports, it has an orchestration framework built in, but it supports an orchestration framework and tools. There's the Foundry agent service, which is a fully hosted agent service. I can show it to you really quick. It's super easy to build agents. And then not only does it support the OpenAI models, but it supports multiple other, the agent service supports multiple other models. And on Foundry, you can deploy all manner of open source models, from Hugging Face, Microsoft specific industry models. And it's really a super open ecosystem that supports all of the latest and greatest agent to agent MCP, lots of connectors, et cetera. So it's Microsoft's like one-stop shop for building agents and AI projects. If you get a chance, check it out. I'll show Magentic 1, and then if I have time, let me know if I have time, I'll show you the AI Foundry a little bit. So this is Magentic 1. I don't have the QR code, but if you go to this URL, it's a point of view on how to orchestrate, there's a bunch of agents down here, but how to orchestrate these agents together. And this whole concept of the task and progress ledger is super important. So a task comes in, you create a sort of methodology or a task ledger on what should do. And there's a progress ledger that's keeping track of, are these tasks complete? Are we in unproductive loops? Is progress being made? So this progress ledger thinks about task adherence to the task. And then it's the orchestrator will decide how to call these different services that are here, right? So it's open source. You can build additional agents or services into this, but it's a really interesting multi-agentic design pattern that I encourage you to take a look at if you want to understand how we do it. And let's see, other agent things. I'll just run through this one real quick. Pirate, get it? Python red teaming agent. Python risk identification tool. So it's a red teaming agent. And what this does is open source again from Microsoft. It's a red teaming agent that will help you test and evaluate your agent. So this code has all manner of attempts to be able to jailbreak your AI applications, test edge cases, etc. So it's an essential part of your responsible AI journey to use the red teaming agent to test your application to make sure that they're not going to get broken, or you can minimize that at least by using this red teaming agent. Let's see. Oh, a couple other agents really quick. Our Microsoft Fabric is our hero product for data unification. So we have Fabric data agents that are conversational agents that allow you to interact with data. So like think natural language to SQL. When your data is in Microsoft Fabric, and again, Microsoft Fabric is our peers would be something like Databricks, etc. So it's a place to unify your data, get your agent data ready, create semantic models of your data, and then on top of this, you can add data agents. So you can ask the data agent for specific insight on the data, and it will go and consume that data and basically act as like a super data engineer. So that's another example of how we're using agents at Microsoft. This just talks a little bit about the end-to-end flow scenarios about how you use the data agent. So you create a data agent, add a source, configure it, publish it, and then it would be easily consumed by your Microsoft enterprise products like Teams, Power BI, AI Foundry, and then also you can create a REST endpoint so you could use this data agent externally, and that's on the way. Okay, so we'll stop with that. Yeah, so let me show you. Do I have a little bit of time? I'll give you a quick run through of Foundry because it's a maze. So here's.
Please do.
Yeah, thanks. So here's AI Foundry. When you come to AI Foundry, we have a bunch of. This is just the landing page, right? But it's a really organized way to develop your project. So there's a concept of projects, this AI Foundry projects, this default projects, etc. So we'll go back to the original screen here. So this is sort of our landing page, and we make it really easy for you to develop. So there's the overview here, right? So when you create this resource, you'll be able to get to all of your AI Foundry resources with one URL and one key, right? So this AI Foundry resources will be models you deployed in AI Foundry. It supports the OpenAI endpoint directly. There's also other AI services like our live voice services, our avatar services, our text-to-speech services, all those services. So it's really a one-stop shop for all of your AI products that you might need. The model catalog is super interesting. So in the model catalog, let's see, they had a number of models that we had deployed here. Last count, it was like 11,000 plus models, right? So here we'll have announcements about new models that have come out. The model router is really cool if you haven't seen that. So you'll have all the new announcements up here. And then the model leaderboards of in terms of quality, safety, and how they're rated. And then down here are all the models, right? So the models are sort of organized because our enterprise customers are looking for all kinds of different models. So we'll look at connections, right? So I'm sorry, we'll look at different collections. So there's different collections of models that are here, like directly from Microsoft or from other folks like Databricks, et cetera. You can organize them by capabilities. So if I click on this, it will just give me all the models that are agent supported, meaning supported by the AI Foundry agent, right? So you can use any of these models with the hosted AI Foundry agent. Inference tasks. So if you want to do certain types of inference tasks, the different types of inference tasks will appear here. So everything from audio generation to image generation, et cetera. So you can do that. If you want to do fine tuning, we'll give you all the models that'll do fine tuning and then licenses. So how do we deploy a model out of here? Essentially, you'll take a model. Let's pick GPT-5 Mini, right? You'll take the model. You'll get the model card model here. And you can use this model, right? And you'll get all the different model card information. When you click use this model, you can deploy. There's lots of different deployment options, our global standard, data zone standard. We have these data zone standard because There's customers in different countries and all over the world, because I know we're streaming everywhere. But there's data zones, like there's countries that have data zone requirements, or the data can't leave certain borders. So you can deploy like that. There's many other deployment types too, like we have provision, throughput, and there's maybe 6 different deployment types. This particular one is only available in these 2 right here. But yeah, so you pick the deployment type you want. We can customize it, right? So in terms of how it's going to upgrade, the model version, etc., the token rate limit, so you can control how much is being spent. And then this content filter, this is the default content filter. So what this is the Azure Content Safety. So by default, you'll go out with this filter, right? And I'll show you that in a second. So what we do is we wrap Azure Content Safety on the input tokens and the output tokens by default. So you can configure that, and that basically protects your model. So when I click deploy, we'll turn this down a little bit. We deploy the model, and the model will be instantly deployed and available to use. Yeah. So we'll let that go. And then the model is here. You'll get code samples by SDK. You'll get different authentication types. You mentioned you can do key authentication. The Entra ID authentication is the keyless authentication that uses the Microsoft basically managed identities. Examples in different languages, of course. Your keys if you want the API keys. All the things and code samples of how to run it. Yeah? Okay, so that's how you deploy a model. We have different playgrounds. So there's some cool ones. There's the video playground. There's the audio playground. I don't know if I have anything deployed here. Yeah. So in this one, we're on. I'm not going to do it because we're on a call. Maybe I'll try it. But what this does is it uses our latest voice model. Let me see if it's listening. Hello, can you hear me? Okay. Can you all hear that? I don't know if you can hear it or not. I know you can hear me.
We heard something, but it wasn't clear. Maybe you can tell us.
Yeah. So basically, what this does is it's connecting to the real-time voice, and there's several real-time voice APIs. So basically, with this, I gave the model some instructions. I can automatically generate a system prompt here. So I can say, give me jokes, and if I want. It'll automatically generate the system prompt for me, so I don't have to think a lot if I'm doing a quick demo. But what this allows you to do is it allows you to test the Voice Live API. So I said generate a system prompt, and all I said was give me a joke, and you could see it crafted my system prompt here, right? You could choose the voice that you're using. You could set the server turn, like when it's deciding when it's someone else's turn to speak. And you can set all the parameters. So basically, this is the audio playground. It's super cool to play with. I did you won't be able to hear it, but I did a demo. You can actually tell it to listen to how the user's speaking and sort of replicate their accent. And you can have it say, hey, speak in a crazy accent, and it'll, not crazy accent, but you can say speak in any accent, and it'll actually do it. So it's amazing. The video playground, same thing. You can try the Sora models. So you have examples here. You can generate your text. I believe it's Sora, and we have other models that are actually other video generation models. So you can play with everything here. There's the images playground that'll use all the latest images products, speech playground. So there's all these playgrounds. We'll go to the assistants, the agents playground in a second. But let me go through some of these other things because we're going to go back to agents. So when you go to templates, these are actually GitHub working templates from Microsoft. So when you click on these things, these are literally single click or single command deploy templates. You get all the code to create a multi-agent workflow, multimodal content processing, generate documents from your data. And these are all, what do you call it? Sample architectures that you could use, and they use these products. So I won't click on it, but you open in GitHub, the code samples are there for you. Yeah. From AI Foundry, you can do fine tuning. Content understanding is another amazing service. I don't have a slide for this, but this service is literally, I do a ton of document processing, has made my document processing I'll say almost trivial. That's a very bold statement, but it will do It'll do the analysis of the document, so you can figure out what document you have. You can define a schema of your document types of how you want to process. It'll extract the data. It'll process videos, audios, PDFs, Word documents, images, you name it. It's unbelievable. We're just going down the list here. Observing and optimizing. So really important part for responsible AI and agentic development is the tracing and monitoring. So that's all built in to this platform as well. We have over here evaluations. And here we have evaluator libraries. So there's a whole library of evaluations that you could use to evaluate your models. We have red teaming built in. There's automated evaluations. So we really do a lot of work on making, because it's critical, you will not go to production unless you evaluate your agentic systems and make sure that it's performing properly. Guardrails and controls. This is where our content filters live that we talked about before. So I can create a content filter, right? So we'll just go, we'll create a content filter. And here I can set the level of violence, hate, sexual or harm. I have prompt shields for jailbreaking, prompt shields for indirect attacks. You can turn it on or off. You can have block lists and block words. So I can basically set the level of my content filter, right? And I can analyze images or text, right? And this is on the input. Notice I'm on input filter here. So we'll just leave this as is. We can go to the output filter. So we could catch stuff coming in. On the output, we have the same thing. So our model that'll mitigate any generation of violent or hate or any of these things that we don't want. But also you notice different things here. So we can scan for protected material text, right? So it'll block protected material that might maybe if it generates something that's known protected material that you might get in trouble for replicating, you'll block that, and also protected material for code too. So we look at those two things and can scan those. You can, it has a streaming mode basically, and then connection. So I can, after I create my filter, I can assign it to any of these models. These are all the models I already have deployed. So I could assign it to any of these models. We have a default filter here. I'm not going to change this. Well, I'll change this one because we're doing a demo. So it'll do that, and it will replace the filter. There it tells me what the filter is like, all right, and create filters. So now by default, this deployment of GPT-4 will use my content filter number 392 to do its thing, yeah, to protect that endpoint. And you'll get messages if you're hitting the filter or the filter is being triggered, you'll get messages in your application that you have to manage, right? So yeah, and you can come here and try it out, so you can understand how it mitigates, how it moderates content. It can look for groundedness. You can look for protected material. So you just click on these little items. You pick the AI service. You pick the this is a protected lyrics, and when you run the test, it'll analyze the content and come back, right, and tell you that it's been protected material has been detected. So you can catch things up front, right? Monitoring for risks, similar. This makes sure that your all your deployed services are managed properly. So you enable this in the Azure portal. It's going to look for any suspicious activity coming in on your application or your log services. Governance, we really have a lot of services in here. So governance, again, super important. So we integrate with a few services. So Microsoft Purview is obviously Microsoft. So we integrate with these services to add a level of governance and streamline the AI governance of your project. So I would say if you're interested in AI governance, which is super important, check out these different services. So think of them like different types of guardrails for products, right? For your AI systems. And Microsoft Entra is our identity provider. So you can deal with you can create specific identities for agents, right? So just like you're a user, if you work, if you have a Microsoft ID, you can create agent-specific IDs that can be managed and assigned to agents. So this is super important. I would check this out. Also, I'm running out of steam here. We have the assistant vector stores. You can create vector stores. You can upload data. You have models and endpoints for all the different models that you have, and there's lots more here in terms of services, right? So the other things that it gives you is typically when you're creating a project, you are collaborating with folks. So you can create users that are in your project. I think I'm the only user here. You can create connected resources for the project. So what are those? You create a connection. So you can create connected resources to AI Foundry, AI Search, serverless models, Databricks, of course, OpenAI models, other services externally. So what you typically do is what I think you want to do when you create these projects is you have your developers working. When you're in a governed environment, they're not just creating connections willy-nilly to other services. You'd put the approved connections for the services here, right? And they're managed by whomever has the access to do that. And then when you're building an agent or a service, you can go in and access the approved connections, right? So you set up your dev environment, your connection environments, your users, you give your users permissions, and then there's a secure and governed sandbox where your enterprise users can create these services. So that's the idea behind that. Let me go back. Are there any questions, friends, while I'm here? I'm just rambling on. We'll go back to the project. So we're at agents here, right? So I'll show you a couple agents. Let me actually go back to this guy. I'll switch to another Microsoft Foundry project, and we'll go to some agents. So I'll show you some things that agents do. Let's see. We'll go here. We'll go to this outcome planner. So what is an agent, right? The agent that we said before. Let me try this in the playground. You get an agent playground. So what the agent has over here is an agent ID, of course, an agent name, a language model that it's running against. So I'm running this with 4.1. And the agent has instructions, right? And this one is an AI transformation advisor that I basically give it the name of a department and a goal. So care coordination and readmissions. And what this agent will do is it will actually create figure out the business context, the strategic intent of what you want to do, and develop an AI hypothesis, and I'll output all of that, right? And here's a little workflow I gave it. And then what it'll also do is I think there's a connected agent. There's an agent solution designer that'll take the input from the first one and then come up with a bunch of agents to solve this thing. So let's see, department. Let's give it a department. We'll call it the customer service, right? And the goal, what should be our goal? Our goal is to reduce hold times for customers and upsell solid products, right? Products. So this was a demo I made. I wanted it to be this simple so any business user could just say, here's the department, here's my goal. And so what should happen if the demo gods are working, this will go out. So you see it just called a connected agent, right? So it's calling the agent solution designer agent. But the first agent did its work. It came up with the business hypothesis, the AI value hypothesis, and all the things I told it to do. It's calling this other agent to say, hey, here's my business hypothesis. Design an agent, multi-agent system that will do this. So it's going off, and these agents are basically working together, and it's coming up with some output. We'll scroll back in a second. So it's doing this because I gave it specific instructions, right? So what did it do? And I'll show you in detail. So it came up with the, oh boy, it did a lot. So it restated department, customer service goal is to do this. And it came up with the business context, right? It made this, it generated this. A high call volume during peak hours lead to long hold times, limited staff, hindering quick resolutions and likelihood of project upsell and blah, blah, blah. So customer inquiries are mostly routed to a basic IVR with manual triage. So again, this was just designed for demo purposes. So basically came up with the business context because I asked it to come up with some business context. It came up with the strategic intent, the AI opportunity hypothesis of what the opportunity is for adding agents. So these agents will automate call triage, rapidly resolve routine inquiries, proactively detect and upsell triggers, all the things, right? And then from the solution designer agent, it came up with these 4 agents, right? Smart triage, routine inquiry handler, upsell advisor, complex issue escalator. And if you know Mermaid, I like to generate things in Mermaid. It gave me the code for Mermaid, right? So what this is provides me a directed graph of what this actually looks like. And if we can cut paste this in Mermaid later. And then I also asked it to give me a description of how these agents would be, how they'd be orchestrated together. So in words, it tells me how these 4 agents that it came up with would work together, right? And so great. And we see here, we ran it. It tells me how long it took to run, the number of tokens, input and output tokens it took to run this, right? The quality of the AI. So, and I'll show you where I set these. So how well it did on task adherence and intent resolution. So how well my agents did. What tools it used. So it used the connected agent tools. And we could look at the run info. So what is this? This is the run info for this agent. So we could see here, it started, right? This is my input, right? So I gave customer service and my goal. And this is the output, right, that it gave. So, but there's run steps, right? So what happened was it called the tool, right? So we called the tool this connected agent, and we can see the call to the connected agent. So what it did was you could see this query that it has. It's a little bit extended, right? So I just put in the department and the goal, right? But all this extra stuff is what the business outcome planner agent generated for me, right? So unlock upsell opportunities, and AI agents could automate customer triage and handle routine call inquiries. So it came up with the whole hypothesis of what it should do, and it also came up with some ideas. Oh wait, so it sent that. Sorry, it sent that to the AI agent solution designer, and so it sent that to the AI solution designer, and AI solution designer came back with these agents in JSON format because I asked it to generate JSON format. Smart triage agent. Here's the role. It gave me some simulated input, simulated output. Again, another agent, simulated input, output, simulated input, output, and it handed this back to the original agent, right? And so all this stuff it generated. And then here's the final thing was my business outcome planner agent took the information from the connected agent and generated the whole output that we saw. Clear? Right? And we see how long it
Chris,
took.
may I
Please.
jump in with a question? So this has been
Sure.
amazing. And a question regarding exactly this. So multi-agent systems, essentially. I understand what you've been showing us comes from, let's say, a context of one organization, but since agents are the next really tenant of the internet, right? They will be interacting with each other also cross-organizationally. So can you maybe share your thoughts on how those agents would, since they generate value to each other, also potentially exchange this value in a multi-organizational environment, perhaps? And has Microsoft been doing anything in this area? I'm very curious.
Yeah, I mean, we're doing a ton. I mean, Microsoft and Anthropic are working very closely together on the MCP protocol. So that's, that just came out last November. So working a ton on that, and using MCP, you can create an agent as a tool, and that can be your design pattern. Also, the agent-to-agent protocol is something that Microsoft is working on very closely with, I believe it's Google, to develop that. And so those are, out in various phases of development. I think that the work that I do, I mean, before those, we had agents talking to other agents. We thought about agents at the end of the day, they will manifest as REST endpoints, right? So wiring them together, if you use a product like Semantic Kernel or AutoGen, you really are pointing to an endpoint. If you think about your Swagger Open API specification that has expected inputs and has we have a data contract of expected outputs. So short of is agent to agent in production? I don't know of any that are in production right now. MCP, yes, a bunch. But we think about like what in the systems I design. If we think about like shared memory context, I do a lot of work in also context engineering, and I think it's important for enterprise to think about like, what are like, how do I want these agents working together, sharing memory and context, and handing off context and work to each other, So we spend a lot of time designing these process workflows and systems. How do we talk to the other agents? Like there's a bunch of security concerns. Like we want to make sure that the agent we're talking to, we're actually authorized to talk to, right? So we might want to authenticate, or we have registered, we have MCP registries. There's uh, there will be in the future, I imagine, some sort of agent registry services, because that makes sense, similar to model registry services. So all of those things are, I think we're all learning as we go, and understanding like what we understand, all the enterprise security concerns, but understanding what is the best pattern to use. I think we're all working together to understand, is MCP the answer for everything? Well, I mean, it's amazing, but when it came out, it had no security, and Microsoft helped add security and authentication to that, along with Anthropic and our other partners. So I think, for right now, many of the multi-agent systems are working on are all in the same ecosystem, and because we're trying to keep them all in the same ecosystem, we have concerns about security. When we start talking to other services, we're thinking about it very much in the same way as we think about talking to REST endpoint and other partners. So if you look at the APIM Gateway is actually a really good service, and it'll give you Gateway is a great service, API management service. So if you look at this repo, there's an amazing number of services around our API management service that thinks about how do we have our API apps and agents securely talk to model data and tools, right? Using having agent policies, content safety, control token usage, authentication, authorization, et cetera. So I think this is a new application of the service, but like, how do we securely talk to other services that our partners have and other line of business applications? We've done all of this before, right? So these are some new tools. So I think looking at this, there's some amazing design patterns on how we have everything from agents talk to endpoints, and share context with each other here. Did that answer your question? Hopefully.
Yeah, definitely. And we're very excited also about the same protocols, for which we will also show a demo, which shows how Microsoft agents work with OriginTrail through MCP. Perhaps just another tiny thought or follow-up question to that is, going a bit into the future. I really like your chart that showed how we started from zero shots and moved on all the way up that chart to multi-agent systems. So looking at the future, where obviously a lot of things will be further improved or solved, agents will likely start providing services and generating their own, let's say, income, which they could then spend, like think ChatGPT API payments or similar things that the agent might need under the hood. And I'm curious what your view is in this regard, like an agent becoming almost autonomous in the sense of being able to go and interact with other agents and exchange value in a monetary sense through standard APIs, or maybe even cryptocurrency, for example.
It's a very leading question. I mean, this is not my own personal opinion. This is not Microsoft view. I mean, there will be a need for, like in the enterprise, what we see right now is in AI Foundry, we have data services available. There's one from TripAdvisor, there's one from Moody's, and they provide data endpoints. Let me see if I can get one for you. So I'll show you this really quick. So here's what I did. I went here and I said add knowledge, right? And so I can add Morningstar, not Moody's, Morningstar and TripAdvisor, right? And other services. So you can have any number of APIs that you talk to with, that cost money, right? So typically in enterprise, there are enterprise agreements and invoices that go back and forth between companies, and those are relationships that are sort of long term. I think that your question is super interesting. I can't comment on the cryptocurrency thing because that's not a Microsoft product, but I think it's super interesting to think about how these agents will exchange value and also authenticate and authorize with each other. And cryptocurrency does seem super interesting. Micropayments, and we talked about micropayments for many years. But I think all of the payment services have potentially a role to play in helping, right? So from our traditional payment providers to the new and interesting blockchain providers as well, or cryptocurrency providers. I try to be as politically correct as possible, but yeah, it's super interesting understanding how these things exchange value. And also, if an agent
I'm not sure if it's me or if it's Chris. So I think we lost Chris, unfortunately. But I hope you guys are still here with us, because this webinar continues on. I hope Chris comes back, but until he does,
I'm
and
here.
there he is. Welcome back, Chris.
I don't know where I left off, but hopefully, yeah. Cryptocurrency is a super interesting point of view, but also
Yeah, thanks a lot, Chris.
Yeah.
Thanks a lot. Yeah, I mean, it's obviously a topic that is not as close to Microsoft as it might be to us. So it's totally get it that it's not a thing that you can go much deeper on. But thank you so much. This was an incredible knowledge-packed presentation, and again, thank you so much for coming to the webinar. We would
Thanks
like
so much
to.
for inviting me, and it's great to see you virtually, and we met in person. I have approximately 250 slides in this deck, so I could probably go on for another 2 or 3 weeks.
We should do another one. We should do another one. But yeah, I'm sure there will be also more opportunities. I mean, we'd like to proceed also with the second with my presentation.
Yeah, please.
But please feel free to stick around, and we can also make it a conversation, because I think you touched a lot of really cool topics, and I might, if you can stay, if you have some
No,
more
I'm
time.
here. I'm here with you guys. Yeah.
I might just segue from a slide or two towards you, but at the end, also for everybody on the stream, we'll be also showing a demo of how what Chris has shown us, or a part of what Chris has shown us, integrates with OriginTrail. So if you'd like to see that, and if the demo gods are on our side, like Chris said, then I think it will be exciting. So having that said, I'll go ahead and share my screen. I also have a lot of slides, but I'll try to make it somehow a bit more condensed. So now the question is, why does this button not let me? Oh, okay, share. Cool. There it is. I hope there it is. Yeah. So this has all been discussion about how we apply agents in the enterprise domain, and you've heard incredible amounts of knowledge and experience from Chris, who has seen this in firsthand from Microsoft. We're actually going to share how we have seen this from OriginTrail perspective, where we've been deploying enterprise systems for over a decade now, and lately, obviously, AI agents, or what we call DKG agents. And I'll just quickly start with a problem that is something that kind of known, but it's not necessarily the thing that is put in the forefront because we're all excited about agents. But I think it's very much worth mentioning, which is that LMs, which are incredible innovation, are inherently statistical, and therefore they can do something like this. I screenshotted a tweet by Gary Marcus, who is also been with us previously at DKG last year, who is considered one of the biggest critics of AI, an AI engineer himself. And he finds examples like this, where you see these images and other types of answers coming from LLMs that are a bit weird, showing something of a situation where they cannot actually not be fully relied on. So issues such as hallucinations, we've all heard about, are something that come from this nature of statistical um, guessing of the next token that is actually the way LLMs work. But it's not the only problem or pathology. And so I'll quickly run through a few so it gives context to why we approach agents the way we do. Another one is obviously privacy. It's one thing to think about privacy from an enterprise standpoint. Obviously, no enterprise wants their data to be up for grabs, but also from a personal standpoint, privacy is incredibly important, and especially in the day and age where people are just less reluctant to share with AIs, and all of those being essentially taking over data. So it's a question of data ownership and intellectual property as well, but as well as centralization. So it's a big question of, are we going to live in a world where we're basically relying on a few major platforms that are running these models, which basically suck up all the information and in some way a lot of the value? Or are we going to be able to use our own agents potentially with smaller models, like Chris said, which can do wonders if applied well and in a privacy preserving manner? Obviously, bias comes into play whenever we have somebody in control in that sense, such as, for example, governance or somebody. Obviously, it's a big thing. And one more thing that's been kind of coming around is this notion of model collapse, which is a very interesting topic. Research has shown that since there's more AI-generated data on the web every day, that means that that data feeds back into the training set of the models. And it turns out that through some um, uh, experiments, it shows that once that data comes back in, it tends to deteriorate the performance of a model. So this could be the reason why we are seeing, at least observing, the kind of flattening out the curve of just not having scaling bring as much value as it used to in terms of LLMs. So these are all issues that are present that obviously won't go away tomorrow, but that need to be tackled in the right approach. And the way we see that approach is really something we call collective neuro-symbolic AI. It's really about a shared environment where multi-agent environment, a multi-system environment, a multi-enterprise environment, which collaborate on the basis of two, let's say, sides of their collective brain, the sides of facts and the sides of creativity. LLMs, being statistical, are incredibly creative. They're really great if you want to write a poem, if you want to write or some sort of story, or generate images. They can do it really well. But when it comes to factual representations of, for example, a bicycle that you've seen on one of the previous slides, they tend to have issues there because technically what they're doing under the hood is they're just really, really, really good guessers. So just like our brain has the left and the left side being more rational and deterministic, applying logical reasoning, math, rule-based inference, we need in this collective neurosymbolic AI this duality as well, creativity being on the right side of the brain, the probabilistic kind, where we have natural language as the dominant model and statistical predictions. And the way we see this world is with the technology that we have been working on and pioneering over the past decade, which is called the decentralized knowledge graph, standing firmly on the left brain side, providing this much needed complement to what LLMs, which are incredible technology, provide on the right side. So LLMs and generally AI models. Chris already talked about this, but I'm just going to quickly recap. All agents kind of have these three major components. We have some system where they have a domain of agency. They act in that system. That could be Microsoft Teams, for example, and it chats with you while you do work, or it can be somewhere else, like on Twitter. Then we have models, which basically do what Chris has shown as planning, RAG, chain of thought, ragging. I was about to say ragging, like I guess I did. And then we have the memory, which is incredibly important. So essentially, a data store, but much more than a data store in the traditional sense of documents. Memory is a place where agents can store experiences that happen to them. And that's what actually is really exciting, especially to me, because I've run into this paper called Welcome to the Era of Experience by researchers from DeepMind, who actually say that we are entering this era right now, that we were previously in the era of simulation. That was back in the day when early AIs of AlphaGo and AlphaZero were winning in chess and Go, which were really, really exciting, but they were symbolic AI. So they didn't have the power, or somewhat symbolic. They didn't have the power that the ChatGPT has, which has really been a model that was trained on, or in GPT in general, and similar models trained on tons, if not all, human data. But we're running out of human data, right? And we're now getting more and more AI generated data. So now actually we're entering this era of experience where the agents will be producing more data for them to learn on, and their experiences or their memories will be something that they will basically base their future actions on, just like we humans do. We learn from experience. I wish I was learning more from other people's experience and mistakes, but I guess it happens more often than I learn from my own experience, and so will likely agents. However, in their world, we can see future, which is not that far out, that these agents share memories and share their experiences, and ultimately, as they go and do actions on the web, they generate more knowledge for each other, and therefore more guidance and better outcomes. So I'm really excited about this notion of the era of experience, because it aligns 100% with what we are doing at OriginTrail. And what we're doing at OriginTrail is really building this decentralized knowledge graph. And you can envision the decentralized knowledge graph as this system on the left that's shown here as these bluish and pinkish dots, which are really nodes or servers in the decentralized knowledge graph network that support agents. So agents, in this case, some are agents, some are more traditional nodes, implemented in the railway system of in Switzerland for several years now, and have been operating across multiple enterprises, and actually leveraging the DKG to exchange information and to discover everything from train parts to events in the supply chains, and all kinds of potential risks in particularly around railways. There's an even full webinar, so I won't go deep into it. There's a full webinar, the link that's shown here, but it's a very good example, I think, to showcase what a decentralized knowledge graph is. It's a really cross-organizational beast that lives across multiple different systems, different vendors even, and connects their information in some sensible way. And now we come to this territory that Chris was mentioning. Okay, what happens? How do we make this secure? How do we ensure trust? Well, this is the key component of OriginTrail. It's called a knowledge asset. Everything is a knowledge asset. And essentially, each memory of an agent is a knowledge asset in our world. What is it? It's a new type of data structure it's obviously very generic. It contains both neural data, if you will, vector embeddings. It can contain those, but it contains knowledge graph structured data, symbolic AI data, cryptographic proofs, which are basically accompanying that information, that knowledge inside of the knowledge asset. I'll explain on those a bit more later, but essentially they ensure trust, provenance, and immutability of this information. And a very specific type of identifier. I was very excited to hear that Microsoft is going into as a specific project just for the agent identification, because I believe that could be something that would well integrate with this, the uniform asset locator, which is a new type of a URL, which is basically self-resolvable blockchain native, globally unique ID. It's a new kind of URI, essentially, that is allowing each knowledge asset to be discovered by agents and verified using these cryptographic proofs, ultimately consumed if they pass certain verification. So when we think about that three-layer system, we basically think about it from our perspective like this. We have a layer of agency, as we talked about it on top, the verifiable AI in our world, which is where A2A, MCP, and other protocols really live. And what we provide is the two bottom layers, if you will, the decentralized knowledge graph, where the symbolic models are essentially created through knowledge assets and reasoning abilities of knowledge graphs, underpinned by trust that comes from blockchains, which here are not used to store information, which a lot of people thought was a good idea. It's never a good idea, both for privacy reasons, but also for scalability reasons. And pardon me, I need to close this window. Rather, it's used for identities such as the UILs I mentioned, ownership, incentives, immutability, and really this ability to capture provenance in a trusted way. So diving just very briefly into these, knowledge graphs are semantic memory. They have this ability to very richly contextualize information. They are very flexible in terms of data models, and they're used across the world for decades now. They're mature Web W3C technology. Initially, were supposed to be, the initial name was really semantic web. And the idea of the mission of the semantic web gave us knowledge graphs, and the mission was that it's an open web of data. Some people believe that it's by Tim Berners-Lee, coined by 25 years ago. Some people believe the mission hasn't been achieved. We believe it has been achieved very much, but it's been achieved within enterprises who had the capability to build these massive knowledge graphs and generate value from all this semantic information. And that there's still years to come where OriginTrail will be obviously continuing on that original vision and expanding it into collective neuro-symbolic AI. Blockchains, on the other hand, they are the trust ledger. And here we see a screenshot of knowledge assets created on a blockchain where we can always see who was the one creating them, when did this happen, and what type of new identifiers or URLs have been created, which basically allow anybody to own their knowledge or their IP, and also participate in governance and incentives. So there's a lot of interesting experiments in the domain and the space of the OriginTrail ecosystem around incentivizing knowledge creation, incentivizing knowledge curation, or what we call knowledge mining, and sharing that throughout the ecosystem. The key principle here is that these memories can be accessed to something called DRAG, or decentralized retrieval augmented generation. So basically the ability where agents are able to discover what other agents have populated in the graph, not having to just rely on their own memory. And that comes with some very interesting problems, such as how do you rank which memories are more valuable or trustable, and therefore topics such as reputation, quality, historical performance come into play. But they also come into play with this positive agent alignment ability, where we can use token incentives and basically reward agents for good activity, which is really, really something that we're looking forward to with OriginTrail. But because we don't have too much time, I'm going to just go and mention how that is envisioned through this notion of knowledge paranets. So knowledge paranets are really these topical knowledge graphs where somebody could launch, for example, their own paranet as a team, and they could launch swarms of agents that go and populate this knowledge graph. So together, agents and their shared decentralized knowledge graph is one paranet where they govern what are the rules, how do we decide which data comes in, how do we incentivize each other, how do we ultimately share this value. And comes with obviously human in the loop. That's incredibly important, where governance is implemented also on the blockchain level. So whoever is a participant of this paranet has the ability to participate in guiding it, and ultimately having the human always in the loop. So if you look at it from another angle, basically what we get here is we have the network, the OriginTrail network, comprising of nodes, and these nodes come in a couple of different flavors. There's edge nodes that can run on edge devices, which can also when I say edge, I don't mean necessarily edge device like a phone. It can also be on the edge, as in running in Azure, for example, and leveraging Cosmos DB, which is one of the graph capable database or generally services within the Azure world, or Amazon Neptune, for example, within AWS world and others. As long as we can use standardized W3C standardized tech, we can plug anything inside of OriginTrail. And then ultimately, as you go up, you have these concepts of core nodes. These are like your core, like your antenna for your mobile phone in a traditional mobile cell phone network, and they are there to host the DKG, so all the public information and all this material that is used by agents to do decentralized RAG. Ultimately, agents really being any type of agent that can plug into the DKG, and I will show one of those in a moment. I think this is the last slide. So basically, what we'll see in a bit is a DKG agent which has the ability to create and query memories from the entire DKG, including different parents. And it's very easy to integrate one because they are the new version of DKG nodes coming out very soon supports natively MCP. So basically, it's a node built around an MCP server, which means that you can integrate any MCP-enabled service with it and very easily connect with it. So this is just about one example of the models context protocol. Chris already talked about it, so I won't go too deep into it, but I'll show a quick demo. And let me see. So I have a couple of things to show. This is, let's see if it works. So the demo gods. This is Copilot Studio. So I'm inside of Microsoft environment, and I'm going to try and chat with my agent. So this is a DKG demo agent. I'll see if it will respond. Hello, DKG agent. How's it going? And let's see. So we can see the agent is thinking something's going on, and then it actually contacted the MCP server. I could see that because it got the list of the tools, but since I asked it something random just to see if it's there, it didn't really connect to it didn't really go to the DKG. So I can come on. What am I? Okay, hello. So for example, I could ask it about something, to query something from the DKG, and I know that in the DKG, because I previously created one such knowledge asset, I created some basic random knowledge asset about John Doe and his phone number. So I can ask for Jane Doe. I think it was Jane. So I'll ask it to query the DKG for John or Jane. I think it was Jane. Jane Doe's phone number. And what will happen actually now under the hood is it actually contacted the DKG node through MCP, and here you can see the result, the triples from this graph coming back to the agent, and the agent understanding the graph here and finding Jane Doe's phone number, which is this 1, 2, 3, 4, 5, 6, 7, right? And it's a very, very easy way to integrate with the DKG. So it's another knowledge source in this case, but also we can use it to publish information. And this doesn't just go with Copilot Studio. Like I can open up, for example, Microsoft Teams. And here it is. You guys should be able to see it as well. So I can ask a similar question here. So, okay, let's try for John Doe's. Query the DKG for. Let's see if that will work, but it should. And so ultimately, what we're seeing here is seamless interaction and an agent that is connected and operating a DKG agent directly with the knowledge base under the hood. And what's great is you don't have to be an expert in knowledge graphs to use it, because the agent is the expert themselves. And these builders of paranets or builders of agents are able to create MCP tools. These MCP tools are now able to guide the LLM, or not even use the LLM if not necessary. They can basically do whatever type of activity or retrieval is really necessary on the graph. And retrieval essentially reasoning So I'll show you something, but basically this is one way to see it in Microsoft environment. The agent also has its own native environment. So there's a like classic, as you can see, chatbot here. And you know what, let's go and let's create a knowledge asset. Let's just, I have something ready here, which I'll use later in the demo, but I'll ask, let's see if it works actually. Hello. And it works. Okay, so please create a knowledge asset from this JSON file. So I'll paste the JSON file here. And what I'm pasting is actually, I prepared slightly. I found some information on NVIDIA and their relationship with TSMC. So what you can see here is actually the agent is trying to call this DKG create tool. So I will now allow it to do so. I can also allow it to do it autonomously, but for the purposes of the demo, I just let it be like this. And now what we're waiting for to happen, it takes a moment or two, is that blockchain transaction that I was talking about. So under the hood, there's a transaction that's actually mining on the blockchain, and it takes a bit for this to execute and to insert into the DKG. But any moment now, if things are okay, this should be returning actually a knowledge asset and a URL towards it. But I'm now starting to wonder if I dropped off the internet or not. So yes, there it is. It was just slow. So we have the knowledge asset successfully created, and actually it got this URL. This is the URL. It's actually a fully qualified decentralized identifier. And if I click here, I can view it in the DKG Explorer. Oh, okay, I know what I did. I made a mistake. When I was creating it, I was supposed to tell it to create a public knowledge asset. So what I'm seeing now is just some private provenance material that I can actually not do much with. But luckily, before the demo, I did it again. So this is what it looks like when you create a public one. It's a very simple linear graph, nothing special. But the point of it is that I wanted to show the ability to actually do this neuro-symbolic reasoning. So relying on more than just the LLM in this case. And so basically here, since we created this knowledge asset, we can go ahead and actually, by the way, what's also worth doing is checking, let's see, who is the publisher of this knowledge asset. And it should know, it should be able to tell us using the get function, because it's going to use this URL. It's now going to go to the DKG and it's going to fetch. Oh, okay, I didn't manage to get it for some reason. So DemoGod's not following me. Let me see if I can get the transaction hash. Can you get me URL? I think maybe that could be it. So I'll allow it for forever. So you can use the agent to inspect this provenance that comes from the blockchain. There it is. So if I take this transaction hash, for example, I can go to this blockchain explorer, I can look it up, and I can find that it happened 2 minutes ago and how many knowledge assets were created in this particular transaction. So multiple knowledge assets get created in one transaction to obviously make this scalable from the blockchain perspective. And what's really interesting now, if we take that data and use the DKG agent reasoning dev tool, I'll take the exact same data. So, and I'll share it. It's a little easier to read. So this is about NVIDIA and their chip vendor, TSMC. To not complicate the example, we probably all heard that the TSMC produces chips for more than half of the world. And this graph, this is something that I discovered, like basically I downloaded from the web. So it's kind of simple. It says that this is a chip vendor, NVIDIA sources from it. It's sources it's GPU model, that NVIDIA is a company, and that TSMC is located in Taiwan and so forth. And now what's really interesting is if I go in the direction of rule-based reasoning, so I'm going to show something which is essentially a way that AI can reason without any hallucination. So I'm going to take one rule here, and I'm also going to explain it and paste it here. Basically, it talks about indirect dependency. So if A sources from B and B is fabricated by C, then A indirectly depends on C. And this is obviously in human readable form. This is in knowledge graph triples form. Again, it's triples and a conclusion. And if I do this, if I click the reason button, it's actually going to add this realization in the graph. So there's another element into the graph. And on the right here, we can see what happened with this reasoning output. So it says we actually inferred through this rule some additional knowledge that wasn't there explicitly before. So if we queried for it, we couldn't find the triple depends indirectly on it. Now it's there, and here is the ultimate neurosymbolic summary. So the LLM taking that result and explaining, okay, what's the conclusion? So we can read it also in human readable form. We can also do another rule. There's a single point of failure rule, which will highlight another. I know because I tried. And if I do reason, now it's going to add even more. So the graph grows with the essentially the explicit rules that we have learned. How did we learn those rules? That's interesting. Well, we can add them as people, but also agents can create them. And that's where we come into that age of experience that is really, really exciting, because we don't have to necessarily rely on LLMs being trained, these huge, massive LLMs collapsing under their own outputs. Rather, we can create very specific trusted information that has a trusted publisher, trusted provenance, rule-based reasoning, and then add LLMs as the right brain to this left brain. So that is also one of the parts of the UIs of this new node that is about to come out in a relatively near future. But basically, as you can see with the DKG, you can create these types of neuro-symbolic AI and launch agents that run in any type of environment, any type of device. And best part of it is open source. So for all of you who might be interested in building agents with the new DKG agentic node, that with this and much more, do give us a ping on Discord. We will be starting with a private beta program relatively soon, so folks will be able to test it and give it a spin before it's fully publicly launched, and obviously also provide your feedback. But from the point of the demo, that was pretty much it. I just wanted to finalize with one more slide, which is why we are doing all this. We as an ecosystem are growing the largest open decentralized knowledge graph in the world of facts, essentially. And how do we create those facts? Well, we have to create them together. We have to somehow know who they come from, and we have to have the ability to plug them in easily into our existing systems in enterprises, especially. So currently, OriginTrail is close to 1.5 billion knowledge assets created on the DKG, and it's growing quite steeply in the last year. And that said, this is the end of my presentation, and I'm gonna stop here, open up for any questions, including for Chris. And also, Chris, if you have any questions, feel free to pitch in. But I will stop here and look at the screen, see if you folks posted anything. Oh, somebody said you cannot see Teams window. Oh, I'm sorry. Did I mess that up? Like, wait, I could show that. Okay, I know what I did. But again, Teams. Where's Teams? Here's Teams. So let's ask it again. Actually, let's ask it. For example, query the DKG about NVIDIA. Tell me what you can find. Okay, let's see if it's gonna go and work like this. But it should. Yeah. So it found basically the triples that I've shown you, and this is the information that it was able to gather as statements from the knowledge graph. So as you can see, two environments that we've shown today, but there's many, many more places where you can plug in this new edge node, essentially creating the ability to use the DKG anywhere within the enterprise environments where this is enabled for MCP. And Microsoft has done a really great job with this. It's so easy to do it. Last time in New York, I was showing how to do it. We're a bit over time now, so maybe not this time, but if anybody wants to try this out, like I promise you, it's not that big of a push. It's a few clicks in setting it up here in Copilot and basically giving your agent a description and making sure that it's so here. Actually, why don't I show it? Wait, I'm not showing the right screen again. So all you need to do is you need to come here. So this is the Copilot agent. You give it a name, description, and essentially here in the tools section, you would add a tool that connects to the DKG agent. So I did this 2 hours ago, preparing for this demo, and you connect it through model context protocol. And once you do this, basically that's it. It runs. All you need to do is then just add in which other application or channel, as it's called here, you want to plug in this team agent. So I wanted to try, didn't have a chance to try to, didn't have the time, but I want to plug it into WhatsApp and I want to try and chat with my agent or Telegram or Facebook. What all I shown was Teams here, but like all of these others are also available, including Salesforce and Slack and everything. So it's really exciting, and I'm really looking forward to seeing people using the new DKG nodes and agents through these applications. Anyhow, I'm going to stop here and open up again for QA. So QA, if there's any questions after all this talk. History is written by winners. I agree with Martin. I don't know where. Yeah, okay. I guess don't see any other questions here. And since it's kind of late here, it's 7:45 Central European time. The cleaning lady is coming to the office and looking at me, and why am I still here? So we'll have to leave in a bit to let her do her job. If no questions directly now on the podcast, we're always also available in the community channels of OriginTrail, so Discord, Telegram. Feel free to come and meet the folks, meet the community, ask around, and yeah, super happy that you folks had the time and energy to join us and listen through for this long webinar. I was excited about Chris's presentation a lot. I'm also incredibly excited about what we're building here, and I hope that it could translate a bit through this first demo, really, of neuro-symbolic reasoning, the way we did it today um, on the web. So I hope it was interesting, and if there's no more questions, I would slowly wrap it up here and let you also folks leave and have a good evening. So I'm giving you 30 seconds to post questions. If no, we close it. Okay, that's not exactly 30 seconds, but I think it was enough to show that everybody's already at the end of the energy. And well, thanks again. And we keep following OriginTrail. There's going to be more webinars like this, including the coming conferences. There's going to be lot of opportunities to engage with other developers in the ecosystem, and think that's it. I want to say once again, thank you. Hope you enjoyed it. Join us at origintrail.io and see you next time.